Hello everybody, welcome to the algorithm course. In this video, I'm going to discuss the breadth-first search. So the idea is like this. For breadth-first search, we need to traverse each vertex exactly once. The top-level vertices are traversed first, followed by the next level until the bottom level is traversed. We need to store the order of traversing the nodes or the vertices in one layer in the queue, which follows the first in first out order. And then we need to traverse the child nodes of each node in the order of traversing the nodes in the previous layer. And then we add the traversed nodes or the vertices to the queue by following the order of the traversal. And in order for us to avoid traversing a node twice, we need to mark the traversed node as visited. And we have to notice something. The search result of the breadth-first search would depend on the order of traversing the neighbors. It means that the result is not unique. So let us take a look at the pseudocode of the breadth-first search. First, we need to create a queue, and we also need to create a set. The set is going to store the visited nodes. And we have to enqueue the first vertex called the start vertex. And we have to add the start vertex to the set called visited that we created shortly. The first 4 steps would involve the initialization of the program. And then we need to traverse each of the neighbors of all the vertices. So we have to do something like this. While the queue is not empty, we need to dequeue it and make the dequeued vertex become the current vertex, and we print out the current vertex to show the order of our traversal. And for each neighbor of the current vertex that we got by dequeuing, we have to check all of its neighbors. If there is a neighbor that is not visited by us, we have to enqueue it to the queue, and then we add the neighbor to the visited set. We have to do the process until the queue becomes empty. So let us see an example of breadth-first search. I want to do a breadth-first search on this graph, and we start the search with vertex S, and the example would follow the numerical order of the vertices when they are put in the queue. So this is our order to follow. So we start with the initialization process. We create a queue called queue, and we create a set called visited, and we start with the vertex S, and I put the node S into the queue and to the set respectively. And of course the current vertex is still empty. Now I want to dequeue the queue so that I have S coming out, and the S will be printed out. That means the first vertex to traverse is S, and S becomes the current vertex, of course. And you can see that S has 3 neighbors, node 1, node 2, and node 3. Okay, and the edges connecting S and 1, 2, and 3 respectively are painted in red now. So we have to check all these neighbors of S. Now let's start with vertex 1 because it is a smaller number than 2 and 3. The current vertex is S. I want to check for the neighboring vertices of S. And 1 is not yet visited. That's why we can enqueue it into the queue. And I also put 1 into the visited set. That's why you can see that queue has number 1 here. And visited has also got 1 here. And the current vertex is of course S for now. And let us check number 2. Vertex 2 is not yet in the visited set. That means I want to put it into the visited set. And of course I also need to put it into the queue. Okay. I need to enqueue it into the queue, okay? Let us check vertex 3. 3 is not yet in the visited set, and of course we have to enqueue it into the queue. And you can see that all the neighbors of S are already checked. So 1, 2, and 3 are the neighbors of S, and they are all checked. And then we can go to the next process. Now we dequeue queue so that 1 has come out, and 1 would become the current vertex, and I would like to print out 1 here. And we can see that 1 has 4 neighbors, S, 2, 4, and 5. And let us check all these neighbors of 1. Neighbor S is already in the visited set, and we can do nothing on S, and that's why we can go to check another neighbor. How about checking 2? 2 is already in the visited set. We just do nothing on 2, and let us go to check for another neighbor of 1. We can check for number 4. So we see that 4 is not yet in the visited set. That's why I can enqueue 4 and put 4 into the visited set. And 5. You can see that 5 is not in the visited set yet. That's why I can enqueue it and I can put 5 into the visited set. And you can see after handling vertex 5, all the neighbors of 1 are already checked. Okay. Now I dequeue the queue so that I have number 2 coming out, and number 2 will be printed out, and the current vertex will just obtain the dequeued value of 2. And when we check the graph, we can see that S1 and 6 are the neighbors of 2, and we are going to check for all these neighbors of 2. The first one to check is S. S is already in the visitor set, and we do nothing on S, and we go to check for another neighbor of 2. Okay, let us check number 1. Number 1 is already in the visitor set. That's why we just do nothing on vertex 1, and we go to check for another neighbor. Now we check for vertex 6. Vertex 6 is not in the visitor set yet. That's why we just enqueue it into the queue, and I put 6 into the visited set. And after these 2 actions, all the neighbors of 2 are already checked. Now let us go to number 3. Now we can dequeue 3 from the queue, and it would become the current index, okay, shown here. And I would like to print out 3 as the next one to traverse. And we can see that vertex 3 has S6 and 7 being the neighbors. Let us just check all these neighbors. For S, it is already in the visitor set. That means we do nothing on it. We can go further to check for another neighbor of 3. Now we check for number 6. Number 6 is already in the visitor set. That means we do nothing on vertex 6. And we are going to do the checking for another neighbor, which will be 7. Now 7 is not in the visitor set yet. That's why I need to put it into the visitor set together with the queue, so you can see that both queue and visited would have 7 to be put. And after handling 7, all the neighbors of vertex 3 are already checked. Now we go to dequeue the queue to get 4. Okay. And 4 would become the current index to handle. So we print out 4 being the next vertex to traverse. And we can see that number 4 has neighbors 1 and 8. So we are going to check for all these neighbors of 4. Now for vertex 1, it is already in the visited set. That means we just do nothing on it. And we go to check for another neighbor of 4, which is 8. Now we can see that 8 is not in the visited set. That's why we can enqueue 8 into the queue, and I need to put 8 into the visited set. And after handling 8, we can see that all the neighbors of 4 are already checked, which are 1 and 8, respectively. Okay. Now we dequeue the queue to get 5, and 5 would become the current index to be put here. And we also want to print out 5 as the next node to traverse. And we can check that 5 has 2 neighbors, 1 and 9, and we are going to check for all these neighbors of 5. For neighbor 1, it is already in the visited set. That means we do nothing on it, and we can go to check for another vertex, which will be number 9. Now for number 9, it is not in the visited set yet, and in this case, we enqueue this number to the queue. So I have 9 here for the queue. And for the visitor set, I also put 9 into it. And after that, I have checked all the neighbors of 5 already. Now we dequeue the queue to get 6, which will be put into the current vertex position. and we print out 6, which means our next vertex to traverse. And for number 6, we have 3 neighbors, 2, 3, and 10. That's why we are going to go through all these 3 neighbors of 6. Now for number 2 here, number 2 is already in the visited set, shown here. That means we do nothing on it, and we are going to check for another neighbor of 6. Now 3 is also in the visited set, shown here. That's why we do nothing on 3, and we are going to check for another neighbor of 6. Now we need to check for number 10 now. 10 is not in the visited set yet. That's why we can enqueue it into the queue, and I put number 10 into the visited set. And after that, all the neighbors of 6 are checked. Then I do the dequeuing to get 7, and 7 will be put into the current vertex. And I also print out 7 as the next node to traverse. And for number 7, there is only one neighbor called number 3. So I'm going to check this neighbor. For this neighbor, it is already in the visited set. That means I can do nothing on it. And after handling number 3, all the neighbors of 7 are already checked, which is just one element. Now we do the dequeuing to get 8, and 8 would become the current vertex, and I would also print out 8 as the next node to traverse. And we can see that 8 has only one neighbor called 4, and we are now going to check for this neighbor. And for number 4, it is already in the visited set. That means we do nothing on this number, and we can see that all the neighbors of 8 are already checked. Then we do the dequeuing to get number 9, which will be put into the current vertex position. And also we will print out number 9, which will become the next node to traverse. And we can see that number 9 has only one neighbor called number 5, and we are going to check for this neighbor. For number 5, it is already in the visited set. That means we can do nothing on vertex 5. In this case, I can see that all the neighbors of 9 are already checked. That means number 5 is already checked. Now we do the dequeuing again to get number 10, which will be put into the current vertex position. Okay, and I also want to print out 10 as the next node to traverse. And we can see that there is only one neighbor for number 10, that is number 6. And we are going to check this neighbor explicitly. For number 6, it is already in the visited set. That means we do nothing on number 6. And after that, we can see that all the neighbors of 10 are already checked. Now we see that the queue is already empty. It means that we can do nothing further from the algorithm. It means that the search is now complete. We can show the breadth-first search result in this way. Of course, this result would depend on the order of traversing the nodes in some order. In my case, I follow the numerical order. So you can try out other ways of printing out the sequence, and you can post your answer in the comment section below the video. Thank you for walking through the algorithm with me. If you have any questions about my video, please post your questions at the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.